Hello everyone, we have to explain the problem on concrete column for the Som MOS subject for civil and mechanical student. Take a one problem. These types of problem fix asked in exam. RCC column 300 mm into 300 mm is reinforced with 4 bars of diameter 20 mm. That means the steel diameter are 20 mm and load 400 kilonewton. Modular ratio is 15. Calculate the stresses of concrete and steel. Okay, first of all we are draw the figure. RCC column is cross section 300 into 300 mm. Okay, then we start the problem. This is a column of steel. This cross section area is 300 into 300 mm. Okay, this column has reinforced with 4 bar, that is these types of 4 steel bars, each of diameter of each 20 mm. Okay, and this column are concrete fill inside this. Okay, first of all in this problem RCC column is 300 mm into 300 mm is reinforced with a diameter 20 mm and load 400 kilonewton. Okay, we have to given that load P is equal to 400 kilonewton. We have to convert this Newton. 400 into 10 raised to 3 Newton. Okay, modular ratio M is equal to 15. We are given this problem, and we have to calculate the stresses steel and concrete. Okay, first of all calculate the area of column. Here in this column area is B into D. Okay, this is a square section of column, that's its area is B into D, that is 300 into 300. Answer is 90 into 10 raised to 3 mm square. Okay, this is a capital A. Second one is area of steel bar. Here in this problem the RCC column has 4 steel bar, that means we are right here 4 into area of bars pi by 4 into d square. Okay, we have to put this value 4 into pi by 4 into d square, means diameter of column is 20 mm, that is 20 square. We have to answer this 1256.63 mm square. Okay, third one is area of concrete. Here area of concrete is, okay, area of concrete is total column area minus steel, that is we have to calculate the how much quantity of cement fill here. Okay, we have to formula area of column minus area of steel. Okay, we have to put this value. Area of column is 90 into 10 raised to 3 minus area of steel here 1256.63. we have to find out the area of concrete, that is AC is equal to 88.743 into 10 raised to 3 mm square. Okay, after that we have to take a modular ratio. Therefore sigma S upon sigma C is equal to ES upon EC. This is the standard formula of modular ratio. Therefore in some problem you are given the elasticities of two materials, that is the ratio of two materials is called as a modular ratio. Here sigma S upon sigma C is equal to elasticities of two material, the ratio is called as modular ratio, that is we have to put here M. Therefore sigma S is equal to M. We get modular ratio are 15. We put here 15 into sigma c. Okay, this is equation number 1. I have to calculate the stresses in two material, steels and concrete. Here total load, therefore the next formula is total load of column P is equal to sigma s as plus sigma c ac. Okay, this is a formula of load. That is that means here we have to solve here. The stress is equal to P upon A. Okay, we have to sum first material, therefore steel. Okay, steel, here load for steel, area of steel, therefore PS is equal to sigma s into AS. Okay, we have to put here this. Okay, we have to put here this values. P is equal to 400 into 10 raised to 3 and sigma s is equal to 15 sigma c, therefore AS is equal to here 1256.63 plus there is no value of sigma c, then it's constant, and area of concrete is equal to 88.743. Okay, calculate this value. Here sigma c both are constant, therefore sigma c both are constant, therefore you have to calculate 107.59 into 10 raised to 3. Here sigma c, get here sigma c, and this value is also here, therefore sigma c, here this value are multiply, here transfer this side, it will be get divide for load. Okay, this one value 107.59 into 10 raised to 3 is equal to sigma c. We solve this, we get sigma c is equal to 3.71. Here unit of stress is Newton per mm square. Okay, put this value equation 1. Put equation 1. Here equation 1, sigma s is equal to, here write down this equation, sigma s is equal to 15 into sigma c. Put this value of sigma c here, therefore we get 15 into 3.71. we get the value of sigma s is equal to 55.65 Newton per mm square. Okay, we get the stresses for two material, sigma c stresses for concrete, and here sigma s stresses for steel. Okay, we have to understand this problem, find out the stresses for steel and concrete. Okay, अगर ये वीडियो आपको पसंद आई हो तो आपके दोस्तों को शेयर और सब्सक्राइब करो.